So we want to welcome everyone to tonight's webinar from the National Weather Service in Boston. This is a review of our February 13th, 2024 winter storm. For those of you in the Boston area, it's kind of what happened. It definitely was the jackpot across closer to the South Coast, especially from Hartford toward Providence. And even Cape Cod and the islands got into the action for a little bit at the tail end of the storm. But for many of us, me included, who live closer to the Boston area, it was more or less a shutout. So we're going to dive into some of the model information a little bit. I'm going to bring up three general points to what we kind of concluded from the storm. And as always, I want to thank a lot of our staff for helping throw this together so quickly. Really, it was just a couple of weeks ago, and we were able to put the event review together. And I wanted to get it out to everybody here while it was still kind of fresh in our minds and before it really got into spring weather, which we know we're going to be experiencing this week. So this was, a forecast bust, no doubt about it, roughly near and north of the Mass Pike, including the greater Boston area. We had widespread forecasts of 8 to 12 inches of snow on Sunday that only verified really in Connecticut, Rhode Island, and Cape Cod and the islands. There was a downgrade to a winter weather advisory in Hartford County early Monday morning ahead of the storm, and that was never changed back to a winter storm warning. I'll talk a little bit about that. As you may remember, the models were really on board for a very big hit several days in advance. And if you were looking at some of the models online, we had really strong model agreements several days ahead of time, high probabilities really for significant snow as well. And as a result, winter storm watches for a storm which was going to impact us on a Tuesday were issued on Saturday, several days in advance. And then the warnings were posted on Sunday, really, over 2 days in advance. But then, as you probably remember, the models began a little bit of a late southward shift of the storm track on Monday. This was more pronounced, really on like the GFS during the day Monday, and on some of the higher resolution guidance that we look at Monday afternoon. So getting very late in the ball game. Some of the international models actually did quite well. The UK Met model actually was the first to show a bit of a southward shift to the storm track the week before. The European models started to trend south over the weekend. And the Canadian models I'll show you initially had this trend as well, but then it began to trend a little bit wetter, more toward the GFS model as we got closer to the storm. But still, there were enough questions here that really, I think we had higher confidence going into this than we probably should have. So we'll talk a little bit about that as well. So the three questions that we came up with in the office is really, what caused the shift south in the models at such a late stage in the game? We're less than 24 hours out aside from some of the international models. Really, really strong agreement in not just our American models, but a lot of the blended guidance too, and I'll show some of that, a lot of the very high probabilities. As a result, we kind of think, at least we were in the Boston office probably biased a little bit by some of this early model agreement on big snows. So it's kind of hard to change your mindset sometimes when you see such strong agreement and really high probabilities to kind of back away from that. It's usually very difficult. So the second, we'll talk about that. The second question is why did that band of heavy snow set up over the Hartford area, over 15 inches in West Hartford, occurred Tuesday morning? Why did that happen? That was kind of unexpected. And then for the Boston area, why did we mainly see rain and a later changeover to snow, which really cut down on the accumulation? So we'll talk about that as well. So we've got answers to all these questions here. And certainly if any of you have any opinions, we'd love to hear that as well. We know we have a very educated audience on our webinars, so we're always happy to hear your input as well. But we'll talk about all of these three things tonight. So here's the observed snowfall map, and you probably saw these posted on social media. The main axis of snow was actually across eastern Pennsylvania into northern New Jersey, the Hudson Valley of New York, and into much of Connecticut. Connecticut did very well with this storm, with the jackpot being in West Hartford at just over 15 inches of snow. Northern Rhode Island did fairly well too, 5 to 10 inches of snow in that area and some of the higher terrain. And just edging into Worcester too, about 6 to 8 inches as well. But that amount's really dropped off as you headed into the Boston area, areas to the north. There was a little bit of a minimum, but still 3 to 6 inches in southeast Massachusetts, and a little bit better on Cape Cod and the islands. So the first thing is what didn't happen. Well, we didn't have the what we call merging or phasing of our two troughs, which we like to normally see for big snows. And this is something that the models had shown several days in advance. So as this loops through, and I'll stop it on the next slide, but you can see our southern stream trough coming up here, lifting through the mid-Atlantic and off the New England coast. But watch the northern stream trough here. It's kind of lagging back. And these two never really came into phase with one another. There's the northern stream trough passing after. So the fact that these didn't phase led to a more offshore storm track, and as a result, the heavier snow stayed to the south. It didn't completely miss us, but it was primarily south of the Massachusetts Turnpike. Now, if this phasing did occur, this northern and southern stream together, this would have resulted in a storm track closer to southern New England and would have resulted in more widespread heavy snow. But that just didn't happen. And again, this is looking at the 500 millibar level. This is typically our steering level for weather systems, and it's roughly at about 18,000 feet. So I'll stop the animation here, and you can see the two troughs. Here's our northern stream trough across the Great Lakes, and here's our southern stream trough with all the moisture and energy moving up through the mid-Atlantic states. So this is well ahead of the northern stream trough, and that lack of phasing is on a large scale why we didn't see widespread heavy snow in the area. And really, the models did not pick up on this until nearly the last minute. It was Monday for most of the models. Some of them, like the European, began to show this possibility over the weekend. But for the most part, this really didn't occur until late in the game. So why was that? Well, we talked to some of the folks down at what's called the Model Evaluations Group. They're down in College Park, Maryland, and they really do a big dive into the model performance for a lot of the major weather systems. They also do verification of the models like the GFS and the NAM, and they also are responsible for recommending upgrades. What can we change in the models to make them better? So in this case, and they're actually going to do a deeper dive into this, but we talked to them a little bit about kind of what happened. And it really comes down to convection or thunderstorms over the southern part of the United States, the southeast. And this probably affected the models. So when this happens, the models can't always handle the amount of thunderstorms that occur ahead of these systems. It can actually have effects downstream over us in New England, even though these things occur the day before. So as listed there, it kind of does one of two things. It can either energize the entire system. And again, we're talking about that southern stream trough that we talked about there. That can, either energize it, it results in a more potent or stronger coastal low and brings it closer to the coast. And I think that's kind of what was happening also with the models as we went into Sunday and Monday. They were kind of picking up on this, what we call convection or thunderstorms, and really energizing the southern stream trough, merging it with that northern stream trough, and then really having a fairly potent system. Now, on the opposite side, and this is what happened, as you can see in red, it can rob the energy a little bit and the moisture and cause the storm to really pass more offshore and be a little bit weaker. And that's exactly what happened here. So some of the what's called parameterization, or just think of them as equations that are in the model, usually can handle this. But even to this day, there are some times where they just don't capture it very well, and the results aren't really seen until almost the day before. So that's exactly what happened here. So it was the lack of phasing of the two streams, the northern stream and the southern stream, but it was also the presence of these thunderstorms and a decent severe weather outbreak, if you remember, across the Gulf Coast and the southeast, that really robbed our energy and moisture from that southern stream trough and led to a weaker and more offshore system. So as it says there, really sometimes these factors aren't really known until just about the day before. Even with all our upgrades in computer technology and all the data that's going in, and the expectations that the models are really perfect several days out, that's not always true. And this was a classic case of where the convection really wasn't handled by a lot of the models until it was almost too late in the game. But it was about 24 hours before, so it wasn't a total busted forecast. But we really didn't see the trends go until the day before. So the Model Evaluations Group will also be looking more into this, as I mentioned, and we can pass on more findings from them as we see those. That probably will take a good month or two for them to really evaluate everything. But just a note here on the model performance, that why it really kind of failed in this case. So as I mentioned, the storm passed just south of the benchmark, which is 40 degrees north, 70 degrees west. To you winter weather fans, you know it well. And an offshore track favors really the heavy snow kind of south of the Mass Pike, across Connecticut, Rhode Island, and southeast Massachusetts. Now, on this, it might be hard to see the numbers, but if you look on this weather map, the numbers are the temperatures in orange here. It's not really cold. But ahead of the storm, we were in the mid to upper 30s, even some low 40s along the coast. And really, this lack of cold air, that was another factor that we didn't see a lot of heavy snow, is primarily in the Boston area. And we'll talk more about this later. So again, here's our model for coastal lows, and a track offshore or outside of this benchmark, which is right here, results in heavy snow being limited more to the south coastal areas, lighter snow, if anything, farther to the north, and typically rain to the south, but it just depends on our temperatures for a given storm. So let's talk about now some of the forecast challenges, and this, we'll show this again, but this was the forecast, kind of the last call forecast going in, which was woefully overdone in the Boston area. So we'll talk about that. So an interesting thing we also found out from the model group is about ensemble probabilities. So many of the probabilities that we use, that we'll show you here, that we'll use in our weather briefings, they're not really probabilities, but they're model frequencies. So what does that mean? That means when you see 100% probability, it just means all of those ensemble members exceed a given threshold. It's a good way to estimate probability, but it's really not a true probability. It's just showing essentially member agreement. So when we look at these ensembles, and you're probably familiar with a lot of these, but the number of members is also very important. So our national blend of models, the NBM, that's our kitchen sink model. It pretty much contains everything. It has roughly 200 different members out to the first 84 hours of the forecast, and then about 150 members beyond that. That's a lot. The individual models, like the European, for example, contains 50 members. The GFS ensemble contains 21 members. And the high resolution ensemble that we show, the HREF, only contains 10 members. So it's important to remember, you're going to see more drastic changes in the probability for a lower number of members like the HREF as opposed to the NBM. And something else that we learned about too are called kind of training periods, or think about something like artificial intelligence or machine learning. A lot of the guidance is trained with several years of model and observed data. Our statistical guidance, those MOS numbers that we look at, is usually trained with about 2 to 3 years of data. Some of the national blend probabilities have a fairly short training period, only about 60 to 120 days. And that's due to limitations in computing storage capacity, more or less. So this has a long way to go. The NBM is still under development. It's a lot better than it was even 2 to 3 years ago. But it's still kind of in its early stages of development. So there's a lot more to go, a lot more of the training to be used, and integrate more of that machine learning or artificial intelligence. That's kind of going to pave the way for the next 5 to 10 years of forecasting. So just a quick note on that. So let's look at some of the ensembles. And this was from Saturday. So if you remember looking at the models on Saturday, it was showing pretty much a big hit across the board. And you're seeing the probabilities or chances of greater than 6 inches in about a 24-hour period. So note the very high numbers for the GFS on the top left, the European on the top right. But the Canadian was kind of onto something here early in the game. Notice its probabilities are very low, and they're focused along the south coast. Now, the reason for the low numbers is because there was a lot of spread among all of the members. So you didn't have a lot of member agreement. You had some that were going closer to New England, a lot that were offshore, and somewhere in the middle was the south coast. So it kind of had the right idea. But when we put the total ensemble together, notice it's like a 50-50 chance in Boston for 6 inches, a little bit higher as you're just south of the Mass Pike. So there was, fairly reasonable chances of seeing more than 6 inches of snow from kind of all of the models at that point. And this one, I apologize, it's a little bit blurry, but this is the national blend of models mean snowfall on Sunday, so we're a day later. It has, I'll read these to you, about 7 inches in Springfield, 10 inches up in Lowell, 8 in Boston, and down toward Brockton, 7 in Providence, 6 in Hartford, 3 inches on the Cape, and even less along the immediate south coast. So this was definitely shifted too far north from what actually occurred. There was definitely a bit of a cold bias. Now, the other thing about the national blend of models is it always lags a model cycle. So when you're looking at, say, the daytime run of the NBM, it's actually based upon the 6Z model cycle. It's not the straight 12Z cycle that we normally see during the day. It's one cycle behind. So it takes a while for it to catch up, especially when things are changing rapidly. And this is a look at the chances of 12 inches or more of snow on Sunday. Notice it's way, way north and overdone. It's pretty much 50-50 in Boston and Lowell, a little bit less in some of the valley areas and further to the south. But you can see it's picking up on definitely on the Catskills up to the west, way to the north up in Manchester. It's over 60% up there. So it definitely had a far northward bias a couple of days ahead of time. So one thing that we did discover were, and we've shown this before in our weather briefings, are called the SIPS analogs. And this takes the run of either the NAM or the GFS at different time periods. It assumes the forecast is going to be perfect and verify and looks at past events. And then from that, we can determine some probabilities for various fields. Well, this is interesting because this is Sunday based on the NAM at 60 hours. And look at where it's focusing on. It's all on the south coast with its values of snow exceeding 6 inches. So it definitely, first of all, hinted at the lower snowfall potential farther north and the focus along the south coast than really a majority of all the model guidance. Granted, it is a lower percentage, but it's showing you the axis, and the max is really not too far from Hartford at that point. So seeing this, really serves as kind of a red flag against going big. It should at least tell us there's some uncertainty here, and it's not a lock that we're going to see, 6 to 12 inches of snow across much of the area. So on Monday now, let's move forward in time. These are the daytime model runs that you probably had a look at. On the left is the European model, valid Tuesday afternoon. And note, it's got that separation of streams. Our northern stream is lagging back across the eastern Great Lakes. Our southern stream is already moving off the mid-Atlantic coast and to our south. So a track to the south is telling us that the storm is likely going to track south as well. And on the right is the GFS loop, which is pretty much showing the same thing. So at this time, it's probably late morning. We're getting the European model early afternoon. We're starting to see some big signs that, this isn't going to be such a big widespread storm. Everything is trending south. So if we look at some of the ingredients, and this is one of the key points, is to really look at the ingredients, not so much of what we call the post-process guidance, which are your snow maps, your precipitation or QPF maps, but look at what is causing these things to happen. So we're seeing a loop on the right, but this is up at about 700 millibars, 10,000 feet. We're looking at temperature for the European on the left and the loop of the GFS on the right. So what we look for at this level is what's called warm advection, warm air kind of flowing into the area. And the circled area I have here on the European models is similar to the GFS. Notice it's focused on the south coast. You've got warm air, you've got arrows pointing from the south, which are southerly winds, running up into this below freezing or colder air with winds from the west. So you're getting strong convergence, or the wind kind of bumping into kind of each other. You've got these southerly winds bringing warm air and moisture into more westerly winds, which are holding on to colder and dry air. So where these two meet is where you're going to have a lot of lift, and that's focused just north of the warmer air. Again, Connecticut, Rhode Island, southeast Massachusetts on a larger scale. So that's telling us right there the heavier snow is favored along the south coast. And again, this is the daytime run on Monday. Now, if we go down a little bit, this is about 5,000 feet. We kind of look for the same kind of pattern. It's called warm advection. And the circled area shows you where the most favored area is. We've got the warm air shown by the pink here, with winds out of the east and southeast, running up into cooler air as shown by the blues, with winds pointing out of the east and northeast. So the winds are converging right along the south coast, and just north of that is where you're going to have your greatest lift. So both models on Monday were showing this, that things had trended south and the greatest lift was going to be across the south coast. So as a result, here's our process guidance, as I like to call it. The rainfall precipitation, liquid precipitation. On the GFS on the left, it's showing its max along the south coast. It's obviously still a little bit overdone to the north, but it's definitely showing an axis from Pennsylvania to New Jersey across Long Island and along our south coast. And you could see on the right, the European model's even a lot more dramatic. It's got the heavier precipitation south of New England. It's got a fairly healthy amount along the south coast, and definitely a sign for just a shutout in northwest Massachusetts. But as we saw, this was even a little bit underdone. So the truth kind of fell somewhere in between the two, but they definitely were trending south at this point. So interestingly enough, when we looked at the individual members from the GFS, which are shown here on all these what we call postage stamps, a lot of the members actually showed some pretty big hits. You can see the yellows and the oranges in here. There's a few that really don't have as much, but all of them have some sort of hit here in southern New England. And this is a known bias by the model developers. It's called under disbursement, where there's really despite some of the changes or tweaks that are made in the initial conditions in the model, it doesn't lead to significant changes in the output. So again, this has been a known bias with the GFS for many years, and something they're actually still working on. It's very difficult, I guess, in the modeling world to show that dispersion or differences in the models. So when we early afternoon now, we've seen the European model come in. Now we're looking at the higher resolution guidance. This was the afternoon run from the NAM, and it's got an even more of a dramatic shift to the south. You can see on the left is our precipitation. It's well south of New England. It's a shot out in northwest Massachusetts. Still, a good half-inch or so across much of the area. But to the right, you can take a look at this was our 5,000 foot 850 millibar. You can see where's the lift. It's all heading south of us. So this is where really your banding would be, maybe just north of it. As it turns out, this was probably a little bit too far south, but definitely was sending the signal that everything was shifting to the south. And when we look at our high-res ensemble, remember, this is blended guidance, only 10 members, and 5 of them are from the previous run. So it's not going to show the changes as dramatic as some of the straight models will. But similarly, there's a southward trend here and eventually focuses the axis closer to the south coast. So the trends, as we always say, they're important as well as we go through the days leading up to storms. And similarly, if you look at the probability of 2 inch per hour or greater snow, this was the Sunday night, early Monday morning run. Very high probabilities over our area. So, at that point, it still looked like, it was game on for big snows here. We had the potential for 2 inch plus per hour snowfall rates. But notice on the day shift run, or early morning Tuesday, I should say, the probabilities have really decreased. And now the axis is running well south of the Mass Pike, more focused, again, right toward the south coast, which is where it occurred. So on Monday, during the day, I was one of the people there. After we saw this more definitive southward shift, and especially with that afternoon run of the NAM, we had a quick collaboration call with the Weather Prediction Center and our neighboring offices to kind of say, okay, we got to make some changes here. We can't stick with the status quo. And our consensus was to rightfully lower the totals in the north and really focus the higher snowfall totals to the south, closer to the south coast. It's a late change, but not too late in the game. We're still a day ahead. We communicated, as luck would have it, we already had a previously scheduled 2:00 conference call with our emergency managers from the 3 states. So as luck would have it, we had the new information by then. We were able to brief all of them. We were able to brief our television meteorologist partners on our internal chat and put the information out on social media as well. We really emphasized that the totals would probably be lowered further in later forecasts in Boston and north of the Mass Pike because we were seeing that trend. And we were really concerned that it'd be a complete shutout maybe up near the Route 2 corridor in northern Massachusetts. But despite making these changes, it's too late for some partners, and we know that, especially for schools who really have to make the call the day before. Just so parents and whatnot can be, prepared for a day without school. So some of our partners need those longer lead times and had to make the decisions that day. So as a result, many schools, especially around the Boston area, were closed for nothing, for, less than an inch of snow. Farther to the south, it worked out fairly well, for much of Connecticut and Rhode Island, and then down toward the Cape. So this was just an example of where we started out on Saturday, showing our highest snow totals in the interior, a little bit less along the coastal areas. And in our final forecast, this was Monday afternoon, was focused along the south coast, not quite as much in the Hartford area that we should have had. It was a little too far south, too much in the north. We trended it south, but not enough. And really, especially for the Boston area. So that brings up another point I just wanted to show you is, how do we produce these snowfall forecasts? It's not as easy as you might think. I wish we could just literally draw with a pencil on our graphical system and have it out there, but it's kind of done backwards. So again, here's just a quick comparison, and then I'll show you kind of the process. So again, the axis wasn't terrible, obviously too high here in Eastern Mass and too high in the north, but definitely a lot to learn from this storm, and we'll talk more about that as we go through the rest of this presentation. So just to show you the process of how this kind of works, and we use a graphical system to produce all of our forecasts, as you may know. We've kind of talked about it before, and it uses different elements that we forecast, from temperature to dew point to wind gust, sky cover, probability of precipitation, things like that, even wave height, storm surge, everything is in there. For aviation, it's got ceiling height. So when we talk about snow, this is probably one of the more complex things that we do. There's a lot of variables, and I like to say a lot of moving parts. There's some of which I'm showing here, but there's actually a lot more. And any error in these is going to lead to errors in the snow forecast. And even the change of a degree or two in temperature will make all the difference in the world. So that's why you might sometimes see, in borderline situations where it's 33, 34, 35. For those areas, you might see the snow forecast kind of flip-flop a little bit. We try to avoid that by being consistent from shift to shift, but sometimes it doesn't quite pan out. But we start with a 6-hour. These are done in kind of 6-hour blocks. So we come up with our 6-hour precipitation amount, and these are usually derived either from the national blend or an individual model or a mix where we take the national blend as a start. We blend in maybe some of the higher resolution guidance as we're getting closer because it tends to do well with the banding. And we come up with our 6-hour total. We also have our chance of precipitation, which is factored into the equation. So from there, then we look at our hourly temperature that drives the precipitation type. Is it rain, snow, sleet, freezing rain? And we also look at snow to liquid ratio across the area. So typically that comes from a model or a model blend, and we can adjust that based upon our own kind of intuition or expectations. And then we also use the temperature for snow accumulation. So typically our default for snow or no snow accumulation is 34 degrees. We can adjust that based on the situation. If we think it's going to snow hard at 34 and 35 degrees, that'll usually stick, especially at night. So we'll raise our threshold there. On the other flip of the coin, we can say if it's 33 and raining or snowing and not sticking, it's light during the day, then we can move it down. So once we put all these things together, we come up with a 6-hour snow total. And then we do that for each of the 6-hour periods during the storm. And you can see on the bottom row, we just simply sum up all the 6-hour totals, and there comes up with our entire storm total there. So it's a pretty complicated process. In most cases, it works fairly well. It's these marginal storms, the ones we've had this winter, the ones we had last winter, that you're going to see us struggling a little bit, especially on the edges. The big storms, the blizzards of 2018, blizzard of 2022, those are fairly easy to do because it's all snow, it's cold. It's just really getting that snow to liquid ratio right, and we'll pretty much be in the ballpark. So not making excuses here. I'm just showing you the process that we have to use. And these are used by all National Weather Service offices, not just ours. And just to show you that there's really so many things that could go wrong. It's kind of, to me, it's a miracle that we even come close sometimes with some of the tools we're using. But having better model data certainly helps. And the improvement in models over the past 5 to 10 years has certainly helped us improve as well with our forecasts. Okay, so just to summarize the key points on forecasting the storm here. As I mentioned, the southward trend was initially shown by the UK Met model, and then even by the European model over the weekend. But the other model guidance, essentially the American guidance, GFS, the NBM, and even the ensemble guidance for some of the models, still showed a big snowstorm for most of southern New England. And this led me to one of the rules that I remember, one of our rules of thumb, and this, for those of you who remember Walt Dragg, this was one of his. Well-known forecaster here in Boston in the 80s and 90s and early 2000s. If the European models and the UK Met and European models aren't on board together for a big storm, you should be wary about forecasting the high amounts. He always noted our big storms tend to occur when both the UK Met and European models are in agreement for a big storm. That almost always works out. So there we go. And after, of course, hindsight's 2020. If we had remembered that, I think going to this, we might have been a little more conservative. But that being said, I think the second point is the main one and was the main takeaway for our staff here. Really focus more on the heavy snow ingredients first. Look at what the banding is favored. Remember, we looked at that 700 millibar convergence and thermal convergence. We looked at that 850 millibar convergence. We looked at the larger scale lift from the separation of those two northern stream and southern stream systems. Instead of starting with the stuff we like to look at, that's the post-process output. I know we all love looking at snow maps, even precipitation. They're the least accurate of all the model fields is that precipitation. So we really should be careful in starting with that and kind of working backwards. So it really can bias us toward higher snow totals. I think it did here. And then you bring in that human element of not wanting to go against those really, really high probabilities, when in fact the ingredients were really showing more of a hit on the South Coast, especially on Monday. And the other thing is, day to day, the blended guidance works very well. But in these situations where you're seeing drastic changes, you have to be careful in using it because it's going to be slow to react. And the other thing is, at longer time ranges, the NBM only includes the GFS and European models. That's out after about 3 days, 4 days. So it's definitely weighted more towards the higher resolution guidance in the shorter term. So just a few key points. We've stressed these with the staff, had everybody kind of go through a longer version of this presentation. But those are really the key points that we came up as far as the models. And again, that second bullet is the one I'd really like all of you to remember. Focus on the ingredients, then look at the post-process output after that. All right, so let's take you through the storm here with some meso-analysis, and we'll go through kind of a timeline as to what happened. So starting off, one of the other issues we found were with along the coast, especially for Boston, it stayed pretty warm. I remember that morning I was heading into work for a 5:30 in the morning shift to help out with the storm. I left my house in the Boston area. It was 39 degrees and raining. I was like, oh, this isn't good. It was the northeast winds, and normally in February, the sea surface temperatures are at their minimum for the year. It's typically in the mid 30s and doesn't do a lot. Even with the northeast wind, it doesn't warm you up. Well, this year, it's been abnormally warm, as you probably know. Our sea surface temperatures are around 40 degrees, which is almost 5 degrees above normal, as you can see in the inset there. And it was the northeast winds were actually bringing us some warming, much like they do in early season storms in the winter. So that was really preventing the Boston area from getting terribly cold. And as I mentioned before, the air mass in place already wasn't that cold to begin with. So here's the map for 7 in the morning, and I've got the green area kind of showing where the warmer air has kind of intruded to in eastern Massachusetts. And notice you've got a lot of onshore flow as denoted by the arrows off the northeast. You've got further inland, the winds are more out of the north. Again, buoys reporting temperatures near 40 degrees for the sea temperature, which maintained our low-level warming. Note, even inland, it's near freezing. It's 33, 31, whatever. That was overcome with the heavy precipitation that kind of dragged the cold air down from aloft. Also, some dry air was in place. You can see there's a pretty big difference between these temperatures on the top and the dew points on the bottom. So this is what we call wet bulb cooling. As the snow moves in, the temperature will crash almost to the dew point. So it's gone down to 31, 33, 31, etc. So these areas where it's snowing hard are going through that what we call wet bulb cooling process, where it's going to crash close to the dew point temperature. While in the east, you've got that steady kind of flow off the ocean, which is keeping the lowest levels kind of warm. So now let's look at the banding for Connecticut and why that happened. You can see the series of images at the top shows us what we call frontogenesis, which is lift due to differences in temperatures. And the purple area that's hatched there kind of outlines where the strongest frontogenesis is. You can see during the night it's developing across Pennsylvania down to Long Island. 3 in the morning it's now starting to strengthen, and by 5 in the morning it's pretty much focused right over southern Connecticut, and really the heaviest snow tends to occur along and just north of this frontogenesis max. So it will be in northern Connecticut, the Hudson Valley, northeast Pennsylvania at that time. And you can see that's exactly what we're seeing on the radar at that point, where all the greens and even some darker greens and yellows were occurring. So there's our banding getting underway early Tuesday morning. Now at 7 a.m., looking at a larger view, you can kind of see the effect of that wet building that I talked about. Temperatures and dew points are pretty close. It's down into the low 30s, maybe as high as 33. But snow is falling in the purple areas, all into southern New England at this point. Generally north of this red line is where the heaviest snow is falling. But a lot of eastern Pennsylvania is reporting heavy snow. Northern New Jersey, southeast New York, Connecticut, even decent snow rates at Providence at that point, and many areas of Rhode Island. So this was right along with that frontogenesis, that difference in temperature, bringing a lot of large-scale lift into those areas. Now, by just before 8 in the morning, here was a look at our radar and some of the snow reports at that point. Heavy snow is spread into Rhode Island. These areas of darker green and even some of the yellows are showing it's snowing at the rates of about 1 to 1.5 inches per hour at that point. And TF Green Airport was reporting about a half mile, and snow had reported 1 inch per hour. You can see there's a total of about 4.5 inches nearby, 3 to 4 inches in Connecticut, but a 7 is showing up in Hartford. Meanwhile, to the north, notice there's not much happening. And if I don't have a loop, but if I did, you would actually see this dry air starting to shrink a little bit to the south and push this banding a little bit further to the south. In the Boston area, it's raining at this point. The radar beam is picking up on the melting layer just outside of Taunton. So that's where you're seeing yellow. It's picking more ice at that point and wet snowflakes. But much of the Boston area was still raining at this point, maybe a little bit of snow mixing in as well. So we can look at a sounding for Boston. I think many of you are familiar with these. The red line represents temperature going up in the atmosphere. The green represents the dew point. So when these are close together, it's fairly moist and saturated. So the model was showing a forecast temperature of 37 degrees and a dew point of 34, where in reality it was actually 1 degree warmer on both with light rain falling. So there was just enough warmth to keep Boston as rain. If you can look closely, this blue line here is our freezing line. So the sounding goes below freezing just a few hundred feet off the surface, maybe about 1,000 feet at most. Below 1,000 feet, it's all above freezing and it's melting the snowflakes. So definitely was cold enough for snow as it's falling down through about 10,000 feet, 5,000 feet, but then melting right near the ground. When it got heavier, that's when we saw some of the mix or even change over to snow in the Boston area a little bit later on. So let's talk about Hartford. Here's our heavy snow band, and it dumped nearly 16 inches of snow in West Hartford. 8 inches of snow fell in 4 hours between 7:15 and 11:15. So what the heck happened there? Well, in hindsight, yeah, we should have reissued that winter storm warning once we had the initial 7-inch report that came in. But at the time, we didn't think that band was going to stay there very long. We were expecting maybe another couple of inches at most. And at that point, we figured most of the snow had fallen. So we kind of let it go, which in hindsight, yeah, that's a definite no-no. Should have gone back to the warning. Weren't expecting to see these amounts at all. But, in talking with some of our TV meteorologists out there, it definitely made their job a little bit harder because here they are showing an advisory on the air when we've got, over a foot of snow falling. That's not good. So something we've made our staff cognizant of if this should occur again. If we get to those warning thresholds and it's still snowing, just go to the warning at that point. Make messaging, more consistent. So interesting enough, I talked a little with Ryan Hanrahan, who was out at NBC Connecticut, a good friend of our office, and he actually tracked the odds of 12 inches of snow in West Hartford from the national blend of models. And if you look at this, the probability is going up to the top here. But we're starting on the left with the early runs on February 11th, running up to February 13th on the right. And, notice they actually kind of decreased with time. We got to a max of about 33%, the day before. And then they actually lowered and went to 0. And the interesting thing about that is the NBM is really, as I mentioned, weighted more toward that high-res guidance in the shorter term. So my guess is those higher resolution models didn't have the banding in West Hartford. They had it to the south, which is, I think, where the NBM, even in the blend itself, was probably biased a little bit by some of that high resolution guidance. So it probably had the banding just in the wrong location, not over West Hartford. And Ryan also shared this sounding. We'll look at a different sounding. This was for Hartford, Brainerd Field, for those of you who know where that is, downtown. And it actually showed a classic heavy snow sounding. This was from the GFS. And I'll point out a few things here. Again, temperature is in your red, dew point is in the green, very close together. So you've got deep moisture going all the way up. And you can see as well, it's below freezing. Here's our 0 line running here. So we're all below freezing. And our lift is by this white outlined area. So to the left, that's our strong lift. So we've actually got very strong lift in this yellow area, which is our max snow growth. That's where you get those big, fat dollar size, half dollar size snowflakes in that layer of -12 to -18 Celsius. So we've got very strong lift. We've got deep moisture all the way up and temperatures below freezing. So this is a classic profile for heavy snow. And I'm not sure when the model run was from. It looks like that was the day before, February 12th, the afternoon run. So by that point, the GFS actually showed this potential pretty well. And I wish we had picked up on it a little bit more. Of course, there's always stuff, in hindsight, it's easier to see. But in the heat of battle, when we're going into this and seeing the model changes, we didn't put enough faith in this forecast sounding, which we probably should have. Interestingly enough, One of our forecasters took a look at the SPC short range ensemble forecast. We use this more for severe weather forecasting than winter weather, but it actually did a great job here. This is about the time of the heavy snow band, and the shading is showing areas where you have some instability, essentially, and the frontogenesis together. And you can see it's focusing it over Connecticut. So it really captured that snow band very well. And the banding that occurs, again, as we mentioned, that snow growth in that layer is so cold, it usually gives you fairly high snow to liquid ratios, more than the traditional 10-to-1. And so the snow accumulations in this area will often be greater than what the model will be showing. And that certainly was the case here. But interestingly enough, something we use for severe weather, we don't use it too much for winter weather. Maybe we should use this as kind of a second check, because it really did a very good job. And even showing the extent of snow into southeast Massachusetts, Rhode Island, and the Cape and Islands. Okay, so now we're moving on to about 10 a.m. Tuesday, and the focus is starting to shift out of the Hartford area now more into the southeast part of Connecticut, Rhode Island, and southeast Massachusetts, and that's where we had our greatest lift. This was actually giving us a fairly decent burst of heavy snow, even at our office down here in Norton, but the surface temperatures were just a little too warm. It was sticking, but it was really fighting to overcome those 33-degree temperatures, which were kind of marginal for accumulation. But there was heavy snow down in that area. Meanwhile, at 10 o'clock, we look at our station plot, and you can see the winds in eastern Massachusetts now are starting to turn a little bit more to the north. It's cooling down, still above freezing in Boston and areas to the South Shore, but temperatures have started to drop. In the interior now, north winds are really locking in the cold air, so it's no issue staying all snow there. Same thing kind of in Rhode Island, and we're starting to see that now into southeast Massachusetts in the banding areas too. And notice the colder temperatures, that's due to that wet bulb cooling that I was talking about earlier, and the heavy snow, dropping those temperatures near freezing. And then by 1 o'clock, it's finally starting to snow in Boston. The winds have backed a little bit more, now coming a little more off the land as opposed to right off the water. It's down to 33. Boston has shown that wet bulbing going on. Down into the mid-30s across eastern Massachusetts. Snow wasn't sticking too much at this point, except really on the grass. And once the heaviest precipitation was gone, that would really be the end of it for the accumulating snow. And you can see by 1 o'clock, the snow has ended across the Connecticut Valley areas. So this is a look at the NBM, the National Blends Forecast. This was the one actually issued that morning, which wasn't so good. It was the red axis is its outline of 8 to 12 inches where it was forecast. Notice it was south of there, and even for Boston, it was way overdone, showing 2 to 4 inches. But at this point at 11 a.m., it was still raining. There wasn't even any accumulation left. So definitely was a little too slow to catch on to the trends. So in summary, we'll go through. Again, the models hinted at this coastal storm almost a week in advance. We had increasing model agreement, very high probabilities for significant snow, led to fairly early issuances of the watches and warnings over the weekend. As it turned out, the watches actually verified fairly well. We aimed for about a 50% success rate on that, and that's kind of what we had. The warnings had a little bit too much false alarm, especially Mass Pike, Boston, northward, where there were warnings up, but they did verify to the south. So, 50-50 on that. That can definitely be a little bit better. The southward trend we talked about was initially shown by the UK Met model, then the European. But really, the other guidance still showed a big snowstorm for most of southern New England, even through the Sunday night, early Monday morning model run. So again, just a reminder, if the UK Met, the European model aren't on board for a big storm, really should be wary about going with overly high amounts. And our big storms usually occur when both of these models are in agreement. So stuff you can definitely check out online and see for yourself. Really, again, the thing I wanted to stress to our staff was to focus more on the ingredients first, looking at where the banding is, where's the larger scale lift, instead of going right to those nice maps of snow or precipitation. Those are more prone to error. So it's really important to we say put on our forecasting hat and do the forecasting. Don't just take the model guidance at will and go with that. And this definitely biased us, I think, more toward higher snow totals, especially from those high probabilities over the weekend. And finally, just really stay away from the blended guidance in these situations. Again, day to day is very, very good. But when we get into situations like this, especially with marginal temperatures for snow, it's going to be slow to react, again, slow to react to rapid changes just because it's a blend. So with that, we will pause here, and I'm sure we have a lot of questions. So I'll take a minute here, and we'll start going through some of those. Let's see. Let me take a look at the top. So let's see. Let's see. From Sam, did the so-called weather alert day messaging on local broadcast media contribute to the reaction of a miss? It could. It certainly could have. Again, there were areas that did see quite a bit of snow. Especially like we talked about Connecticut, Rhode Island, and really Cape Cod and the islands. They saw most of their snow in about a 2 to 3 hour period with near blizzard conditions. So there were a lot of power outages there. I should have mentioned that. The reaction to a miss, like it or not, a lot of people live in the Boston area. And if we miss Boston, we miss Providence, we miss Hartford, that's going to impact a lot of people. It's possible. I think the fact that we went with the watches early on Saturday, that's not a bad thing, but I think it started to maybe lock people's opinions into that there was going to be a big storm. And sometimes people hear the first forecast maybe over the weekend of 8 to 12, and then that's what they remember. They may not pay attention to later forecasts. So, yeah, it could be a little bit of both there, Sam. I'm not really sure, but yeah, certainly, the earlier maps that went out kind of maybe just, drove people to that conclusion as well. From John, is there any effort to incorporate artificial intelligence or machine learning into the models? Perhaps they could improve themselves with real data. Yes, there is. As I mentioned, that's kind of what the research is into the next generation of models is happening now. It's starting now with a lot of the severe weather modeling that's being done. So we're actually using that for a lot of the forecasting for things like high-end severe weather, for tornadoes, for flash floods. That will make its way into winter weather as well. I think you'll start to see a lot more model output from that in, say, 2 to 4 years, maybe 5, 6 years at most. It's going to be a gradual process, but that is underway now in the model development world. And I think we'll be seeing a lot more of that. That's kind of the next frontier in forecasting. So stay tuned for that. From Tom, it's his opinion that dynamic cooling that we talked about in these marginal events is driven by the hydrometeors cooling the boundary layers. Yeah, absolutely. That's exactly what it is. So if the lift is weak, the boundary layer or near the ground isn't cooled sufficiently to maintain snow. Instead, you get light rain from exactly because there's not enough cooling. That's exactly it. So what you see is, the heavier precipitation leads to that cooling. It drags the cooler air down. It forces the temperature closer to the dew point. So exactly. Let's see. The drag was, let's see, Tom also mentioned the drag was a principal factor. No, what I mean is it drags the cooler air down with it, kind of like in a summertime thunderstorm, bringing the cooler rush of air out with it. That's all. That's what I was talking about. So just the same term, but different thing. And just what is CSI called? Yeah, that's the instability I talked about, the banding. It's called conditional symmetric instability. So there's 2 types, and we talk about that. If you go to our Winter Weather 101 webinar on YouTube, we talk about this a little bit. There's 2 types of convection. It's called upright convection, and that's our typical thunderstorms in the summertime. The warm air rises, cools, and condenses. We get the instability. But there's also something called slantwise convection, and that's what we see in the winter. It's not straight up and down. It's on a slant. So it starts off in lower levels and gradually works its way up as you head west or east. So this is where we look at the things like that frontogenesis that I showed. And that's how you can tell what the banding is. It's conditional symmetric instability. It's a fancy term, but you can also search it online and you can find a lot of information about that. From Sebastian, does the HREF, the high-res ensemble, total snowfall output assume a constant 10-to-1 snow-to-liquid ratio, or is there an algorithm that's utilized in order to account for the changing snow-to-liquid ratios? Yeah, it's all 10-to-1. So a lot of what the model snow maps that you see are straight 10-to-1 ratios. They're not using anything other than that. Like, for example, what you might see from the National Blend uses its own snow-to-liquid ratio. It's not 10-to-1. So it really depends on the source. But as I remember, the HREF is a straight 10-to-1, as is most of the model output that you will see. So that's always an important thing to account for. From George, is the frontogenetic banding very hard to predict? Often it's a game time decision. Yes, that's another thing. Often the models will show the lift in the right place, but they'll put the heavier precipitation too far to the south. So in other words, if we have very strong banding maybe from Providence to Boston, that's not, the model will show the heaviest precipitation there, but often it will go to the northwest. So it might end up being closer to Worcester, for example. It is difficult, but if we look at the ingredients, as I mentioned, that's really where you can make a little more money in the forecasting and identify the right area. From Jeffrey, do you think that AI is going to change how you interpret your models? Potentially, but I think it will also improve the output quite a bit. I think it's going to be using, a lot of past history, a lot of past data, and look through a lot of data in a short time to help us out. So instead of us having to pour through mountains of data, it's going to take care of all that for us. But yeah, the forecast process is going to change, I'm sure. As the model data gets better, we'll have greater reliance on it. We're starting to do that now with the national blend as far as using it as the basis for our forecast day to day. There are definitely times where we improve upon it. We get into a springtime warmth pattern like we have this week. The blended guidance is too low. We know that. Radiational cooling night, it's too warm. And a situation like this, it's going to be off a little bit. So yeah, I think there will be a change in our forecast process as we start to see that mature. Let's see. Oh, my friend Fred is on. Let's see. Yeah, school system cancel classes way too early. Yeah, I think it's just a sign of the times. We have some folks that need to make those decisions a little bit too early, especially the larger cities. In this case, we actually talked to the emergency managers on that conference call and said, you know what, if you need to make any decisions, it's actually best to wait till the morning because we know this is even going to change a little bit more, and it could be for less snow. So they were able to work with that in their action plans. But sometimes the schools just have to go a little bit sooner. That's just the way it is kind of these days. And from John, what were the parameters that drove the overestimate of the long-range models? I guess you're talking about the snowfall and the probabilities. Yeah, good question. I think it was just going back to that bigger picture with the two streams, the northern stream phasing with the southern stream having a lot of available moisture and a storm track closer to New England. I think there was just a lot of agreement that was going to occur. And it really wasn't until maybe a day or two ahead when the models started to do a little bit better with those storms coming out of the Gulf, the thunderstorm activity, that they started to get a better handle. And then the numbers started to shift and go south. So that would be my guess. From Robert, because of the warm sea temps, you've noticed the warm layer extends to Norwood and probably another 5 miles. But interesting, in southern Hopkinton to pick up 6 inches. Yeah, in this case, the coastal plain, the warmer air, quote unquote warmer air, just kind of flooded right in and hung tight. So it was those higher elevation areas. Hopkinton did very well. Areas, the western part of Norfolk County did get some accumulating snow, but it was just those lower elevations right along the coast that, the warm air went right on in. And those warm temperatures, it was more reminiscent of an early winter storm than a February one for sure. Let's see, for JP, the point forecast hour-by-hour numbers for Springfield didn't seem to show the higher numbers forecasted elsewhere. So those numbers actually come right from our database. They're the hourly numbers. Because of some rounding that's done, they don't always match up to what you're going to see on the snow map. They usually tend to be a little bit lower. That's kind of a known bug that we have in the software. So it's something that's being worked on. So if you're looking at the hourly forecast, those are typically very good, but you'll notice the snowfall amounts might not quite stack up to what's being forecast. So just use those with a little bit of caution. And from Tom, let's see, what is meant by deformation related to convergence? Yes. So that's kind of the zone, just in simple terms, where you've got that wind convergence. So as I showed, you had the southerly winds coming in off, the Atlantic, and then you had those kind of westerly winds across Massachusetts, closer to the Mass Pike, and that deformation band is higher aloft. It's usually up at the 10,000 foot level, but it's an area of wind convergence, essentially. That's what it is. And that's why we often see two big snow bands with our winter storms. One is that deformation band, which is starts at about 10,000 feet. That typically shifts more inland. And then we have our lower band of snow that usually is associated with the coastal front. So the one that moved through Hartford was more with that deformation zone aloft at about 10,000 feet. From Max, let's see. Oh, we missed the first 45 minutes. That's okay. Not sure if this was explained yet, but what caused the further north than what we expected in the Monday night heavy precipitation shield? Got about 8 inches of snow here in Massachusetts. It was further south, actually. things gradually ramped to the south with the storm. So things trended Sunday night, early Monday morning, things were still on track for big snows, and then things really started to shift south as we got into the daytime on Monday. So yeah, some areas did pretty well, especially with higher elevation, south of Worcester, just over the Rhode Island border in particular too, and over toward Springfield too. Did get some accumulation as well. So those areas did relatively well compared to areas further to the north and to the east. From Carlo, what was the reaction in the office when you started looking at the new lower snow totals? We were like, oh boy, for one thing. Luckily, it wasn't too late. I'm glad this didn't happen Monday night and Tuesday morning. But we definitely started seeing the trend, and there were 3 or 4 of us working, and we said, are you seeing this? Yeah. And then we started looking at a little more at the ingredients, saying, oh, this is going to be south. And there were questions in Boston about the warmth. Would it be cold enough? And there was still uncertainty there. So there were a lot, like I mentioned, a lot of different moving parts with this storm. But overall, it was like, okay, we got to get the message out that this is first going south, and the heavier snow would be Connecticut, Rhode Island, southeast Massachusetts, and areas to the north, especially Route 2, may not see much of anything. Boston was still kind of a question mark again because of the borderline temperatures, but we were definitely leaning toward less snowfall. It didn't show up on that last map as much as we wanted it to, but to meet our time deadlines, we had to get something out the door. But yeah, definitely, at least we saw it coming kind of late in the morning, and we had enough time, a day ahead of the storm, to kind of inform everybody. And again, as I mentioned, as luck had it, we had a conference call scheduled with our emergency managers at 2:00. So we were able to convey that to them. And we actually had some feedback. We solicited feedback from the Connecticut, Rhode Island, Massachusetts, city of Boston in particular. And all of them said no, they were prepared. Boston decided to go the route they did just because they wanted to be ready for the worst case if things shifted back north again, which we weren't confident was going to happen, but we couldn't rule it out either. So, they said everything was fine. Connecticut had no issues. Rhode Island had no issues. Overall, the emergency management community was good. Again, I think a lot of this was also the help of our TV meteorologists getting, a consistent message out that this was moving south. And I know a lot of you on this webinar are the ones who pay a lot of attention to the weather, so I'm sure you saw these trends as well. It really, I think, comes down to the folks. Once they hear the first snowfall forecast a few days out, for better or for worse, that's, what they remember. And obviously things change. So that's why we tell people to always check back. But, not everybody's going to do that, and that's fair enough. So there were a lot of, I would say, disappointed people, snow lovers. That's certainly understandable too. But, even in this day and age with all our advances in technology, I think, a lot of us rely on these models as doing very well, and they often do, but it just goes to show you they're still not perfect. There's still cases where they struggle. And this was certainly a really good learning experience for our staff, both from forecasting, but also from communications. How do we communicate these rapid changes a day ahead of the storm, saying, hey, things are changing now, how do we get the word out? So, we'll continue if we see events like this in the future to work more on that. So yeah, and also let's see from Robert, hope it's presented at this year's winter conference. Yeah, we'll certainly be presenting this, perhaps the Southern New England Weather Conference a little later this year. We'll do that. As well. But we'll also share this research. As I mentioned, we're working with the folks at the Model Evaluations Group. We're going to be doing an internal weather service presentation with them next month. And this will probably show up at some area conferences as well. So this won't be the last of it. And I see a last comment here from Max before we get to our weather briefing. Notice the Hartford area got 12 to 16 inches. Was this due to a little bit of extra energy? If so, if we did not have the unexpected southward shift, would we have seen totals over 16 to 20 inches in Massachusetts? Yeah. So as I mentioned, that was that banding that's set up from Pennsylvania over to Connecticut and even into parts of Rhode Island. If this had shifted a little bit north, that definitely would have been into Massachusetts. Maybe not so much the Boston area, but I think western and central Massachusetts, somewhere in there would have seen this band of 12 to 16 inches. So yeah, just a little bit too far to the south for snow lovers, unfortunately. So all right, with that, I will pause our recording here for tonight's webinar.